Welcome to the Fireside panel. It is on algorithms, transparency, and accountability, in large part because of the work of the people here in this room who are now taking their seats. Machines have become dramatically better at many kinds of critical decisions, not all of them, but in areas ranging from medical diagnosis, hiring, credit, parole, many others. There's been striking performance in many specific areas, and new breakthroughs are being published almost daily. We saw this afternoon, the panel on data-driven decision-making, that a lot of these effects could be measured at the firm level, perhaps even experimentally, and making companies more productive and more profitable on average. But at the same time, I think we've all seen that there's a growing backlash against these algorithms and some of the companies that are using them, particularly around concerns around bias and lack of transparency, perhaps lack of fairness and other issues. There are books like Cathy O'Neill's brilliantly titled Weapons of Math Destruction. I just checked, it is #1 in Amazon's privacy and surveillance category. So it's not just interesting that it's #1, it's also interesting that Amazon has a category called privacy and surveillance. And it got a lot of good reviews from places like Nature, saying that it reveals that the pervasive algorithms in our society are, quote, riddled with bias. We also know that the AI Institute has recently released a report, a little earlier this year actually, on a proposal for algorithmic impact assessments. They say, quote, the report describes how affected communities and stakeholders can use our framework to assess the use of AI and algorithmic decision-making in public agencies and determine where or if their use is acceptable. In fact, the mayor of New York shortly thereafter announced a new task force to, quote, develop a process for reviewing automated decision systems, commonly known as algorithms, through the lens of equity, fairness, and accountability. So ultimately, I think we all know that the decisions that the algorithms make are only as good as the data that they use, the goals that they seek to optimize, and the underlying algorithms that are being employed. And we all know that there are numerous risks in each of these areas. So this panel will seek to address these issues. And with your help, this is going to be interactive. I'm sure you all have questions and thoughts you want to ask of these esteemed panelists. We're going to explore questions like, what are the implications for accuracy, fairness, and other values? What's the right way to even think about some of these issues? What are the right policies for individuals, organizations, and society? And perhaps towards the end, we can even get into what we can do as a community to do better. I know there are a lot of smart people in this room with a diverse set of views, so I'm looking forward to hearing your questions and comments. But first, we're going to hear from our panelists. And let me start off by, let me just briefly introduce the panelists. We have Susan Athey from Stanford, also was the consulting chief economist at Microsoft. Dean Eccles, my colleague at MIT, where he's in the marketing department. And Edmund Awad, who is over at the Media Lab. And we'll talk a little bit about some research that just came out this week. But Susan, let me start with you. You've said in the past that when it comes to understanding fairness, there are really two different kinds of algorithms with two different kinds of goals that we need to distinguish. And the debate has been a bit muddled because we haven't done that. What are they, and why does that matter?
So I guess if I make things concrete and think about an application like screening resumes, there's two different types of algorithms you could build. One algorithm might be an algorithm that tries to mimic what decisions humans made in the past. And there's just the idea as well, it takes time to read resumes, so why not have a machine do it? And I just want to try to do as good a job as the humans were doing before. A second type...
Faster and cheaper.
Faster and cheaper, exactly. But I guess just in thinking about the faster and cheaper part, if you're just mimicking what the humans do before, you might not really be taking advantage of the full benefits of machine learning because, of course, a human, if screening lots of resumes, is going to look at the school they went to, the gender, how old the person is, and a few key characteristics, what their major was. And as a Bayesian, then you're going to draw inferences based on just a small number of variables. And when we think about...
Even if you're not a Bayesian.
Even if you're not a Bayesian. But as a fully rational decision maker doesn't have time to read everything. And so then you have stereotypes. And if you look at my resume and you see, I'm a woman, then you might think I probably don't write great code. On average, maybe I'm less likely to have been an engineering major, but if you then look at my majors and look at what I've published on, of course, then you don't need to care about whether I'm a woman anymore. But of course, when you're reading quickly, you're not reading all of these other facts in the resume. So
That could be done subconsciously.
exactly, subconsciously or consciously. But even consciously, I see somebody from a bad university, and I'm not going to take the time to figure out that actually they have a great engineering school. It's a mediocre state school, but the engineering school is actually great and puts out great grads. But I might not know that. Now, a machine can figure that out in principle. But of course, if they're just trying to mimic the human decision maker, if the human never looked at that information, the machine won't either, and it won't really be an improvement in efficiency. And it would also replicate.
The machine will learn to be as similar to the person as possible.
Yeah. And that's if the humans are using heuristics, and if they're biased, then so will the machine be. Now, a second thing that you could do, and I think this is often more what people are actually doing in practice, but of course both things are happening, is that you could say, well, I'm going to just instead try to predict who, conditional on interviewing, advances to the next stage. And so, of course, ideally you might want to predict like who rises to be CEO, but of course you don't have a lot of data about that. So you take a short-term proxy, not a perfect proxy, but a proxy for what's a good candidate. And the idea is that, well, if I actually do bring someone in to interview them, then I'm going to gather a lot more information, and at that point, the decision to go to the next stage is more likely to be based on the merits. So if I train a machine learning algorithm to try to predict that, in principle, it will learn a whole bunch of things that are important, and it might actually use information that the humans weren't using before, which would improve on the decision making.
Could it still be biased?
So yes, although I guess what I would say is that on average, I would expect it to be much less biased, because humans do a lot of biasing when they're using little information in a short time, and I think on average humans get debiased by gathering more information.
If the humans had never hired anybody from that state school you were referring to, then there would be no data.
Exactly.
That could work.
At least they would then, if the machine learning, now here's another thing, of course, you can use good and bad machine learning algorithms. They should, if you have a good one with uncertainty quantification, then you might know that you don't know about the person from that university, and therefore you should experiment like a bandit would. And so
we heard a little about that.
The rational algorithm would at that point experiment. Or if you're using simpler algorithms, still the humans could say, okay, here's parts of the covariate space that we actually haven't explored, and if we're going to move to this algorithm, we should invest in exploring a broader space, because actually we might discover something we didn't know before. But just as an alternative, suppose my job interview is, let's just use a bunch of stereotypes here. Suppose my job interview is that we all go out and get trashed at a strip bar, okay? So, and that's how you get to the next stage of the interviews. Well, that might...
Stop doing that at MIT, just for the record.
Then, of course, there would be some obvious biases there. So if the process of getting from one stage to the next of the interview has biases, then you haven't solved your bias problem. And there could be even worse biases at that stage.
Right.
In principle, like biases around how you communicate, how charming you are, how nicely you smile, whether you wore a nice suit.
That could be even worse.
And it could be worse. But I guess part of the reason I actually like the idea of using algorithms for things like resume screening is that my own subjective belief is that actually, although that stuff happens at both stages, there's a lot worse stereotyping that happens, more inefficiency that happens at the resume screening stage than the next stage. And so on average, you would do better to put the machines in place.
Or more generally, the closer you get to your goal function of the ultimate thing you care about, maybe the second stage isn't really ideal either. I don't know if CEO is it, but there's probably some other things that the closer you can approximate that goal, the closer your algorithm's going to be coming to optimizing what you care about.
Exactly. And then another great thing about making it more quantitative is, of course, you can then impose constraints as well. So you could say, all right, first of all, I want to experiment, and I can force the algorithm to experiment in a way I might not be able to do with the humans. I could also impose a diversity mix. Or I could say, let's get some people from underrepresented minority universities, and then you could try to learn, how to do those. And another thing you can do if you going back to fitting an algorithm to what the decision makers were actually doing in the past, you can actually kind of query that and see, actually, was it biased?
So yeah, we're going to get to some of those issues in a little while. So
making it all quantitative, yeah, I'll hold the thought, but I would just say making it more quantitative, I think, in principle, if used well, can be optimized to reduce bias.
Right, and it's beginning to sound like some of the things we've been talking about today, which brings me to my question for you, Dean. I mean, in fact, we were talking at lunch today, and you said that ultimately you could think of this as basically an issue, as a problem of causal inference, isn't everything? But so what exactly do you mean by that, and help us with that mapping?
Right, so I think actually one of the great things that's happened in this area is that the machine learning community, including also lots of people from statistics, has really tried to tackle many of these problems of fairness, accountability, trust. And a bunch of the recent papers in this area pretty much explicitly cast this whole problem as one of causal inference, right? And so this is both in the case of trying to assess bias in existing processes, which could be humans. So once we've modeled how humans are currently screening resumes, that might tell us something about whether they're acting in a biased way, but it's only going to do that if we do a good job of doing causal inference about those factors.
Whether that hire whether that person then ultimately was a good hire.
Well, I was thinking even just more narrowly whether modifying what should be irrelevant protected characteristics of a resume are actually causing people to make different decisions. So that's why, you know, as a community that does a lot of experiments, we do things like audit studies, but in other cases, you might use observational causal inference to reach some of those same kinds of conclusions. So this, in that stage of the auditing, assessing the existence of bias, but also many of the criteria we have for whether an algorithm results in fairness have to do also with causal relationships of things like disparate impact, which is a legal notion, but has been also translated into the language of fairness, accountability, and transparency more technically.
Help us a little bit with both parts of the
Yeah.
What is the legal part of the definition? And then
Right. So I mean, so I'm not a lawyer, so I don't want to dive too deep into that. But generally, when then sort of translated into the kind of computer science and statistics version, is thinking about what are there disparate outcomes? Are there different outcomes for two groups that we want to be caring about equity and justice with respect to? Or are we treating them differently? So we could care about disparate treatment and disparate outcomes. And you know, once you put it in that language, it becomes clear there's just a lot of causal inference problems here. And I think then finally, even to the framing that Susan had just raised, which is, say we want to condition on the idea that a resume passes screening, it passes some possibly biased human process, and then we invite that person on site for an interview, and we're going to try to predict the outcome. Well, we're back in a sample selection problem, right? We have some process that is conditioning on a bunch of variables that we might be able to observe, presumably the human decision makers were observing them, that's causing those people to be invited on site for an interview. And so we should apply all the machinery that we have from the social sciences, econometrics, causal inference to try to get that right, to notice when we have things that are at least empirical positivity violations, where there's types of people where it seems like we never invite them on site for an interview, and perhaps without any good reason. So assessing those kinds of lack of positivity, that's something we try to do in a lot of observational, quasi-experimental work. That's one of the ways in which the tools apply here too.
Great, thanks. So Edmund, congratulations. You had a paper came out in Nature this week. You were the first author, so congratulations. It relates to this as your moral machines work. Tell us about what you did and what you found, and how it sheds lights on these issues that emerge when we delegate more and more decisions to machines. I understand you have a couple of slides to help explain this.
Right, well, thank you. Yeah, so I'm going to talk just briefly about the experiment that we had, which the results went out 2 days ago. We call it the moral machine experiment because the website that we released released 2 years ago. Basically, we call it moral machine. It generates random moral dilemmas that are faced by driverless cars and asks you what you think the car should do in these dilemmas. Like this one, for example, the car could, here we assume the brake fails. The car is going to either kill this group of people who are jaywalking with a dog, or it's going to swerve into the barrier, killing the female athlete. And then the question is, which group should the car sacrifice?
Should we vote on that? Or That's what you had people do, right?
Yeah, exactly. So in designing this, we have used different kind of characters with different kind of tasks and jobs. We also the scenario itself has a different elements, like 4 kind of main elements, which is like whether the car should stay or swerve, whether the people on the street are pedestrians or passengers, whether they are illegally crossing, if they're pedestrians, and what's the type of these people. So in general, we had this interventionism, we had the relation to AV, we had legality. And then on top of that, we have the type of characters. So in this case, we have like a gender aspect, male versus female. Age, we put older versus younger. And then we had like a fitness, social status, species, and number of characters. So we had like those 9 attributes. And we also had the website translated into 9 other languages. We had 4 million visitors to the website. 40 million of those dilemmas were answered. And we had also like an optional survey at the end where people could answer. We had people coming from 233 countries and territories. If you compare this to the map of the lit world, you could see that some kind of a coverage of this area. And in terms of the results, we use kind of a conjoint analysis to do this kind of calculation. So here, like, for example, if we replace pets with humans.
Actually, on that last map, go back one. Is that a map of population or internet access or?
So the one is the one on the right, you mean?
Yeah, the lit world is what is lit?
Nighttime lighting.
Yeah, not. Yeah.
Oh, so you mean like literally? Okay.
Yeah.
So it's not necessarily proportional to population.
Yeah. So here it's like, for example, if you replace the pets with the humans, this is how much people are more willing to spare them. And then the same thing with the sparing more characters. If you add 1 more character, this is how much people will be more willing to spare them. On average, the number is kind of close to if you're adding two characters. And then you can do the same for all the 9 attributes. And you can actually compare the 9 attributes to each other. And you see that here, like the last 3 rows, for example, these are the 3 that most people approve of, which is sparing humans over pets, sparing more humans over fewer, and sparing the younger over the older. Now, with the lesser degree, you can see the low and the social status as well. Also, we could do this at the level of each character because we had like 1 completely random scenarios where we choose like again, like we compare that to adult man and woman, and we see how much people are willing more to spare a baby stroller, for example. And then we could also order the characters. We can see that the top 4 characters are all kind of include young or younger characters. And even at the bottom of the list, aside from the dog, criminal, and the cat, you could see that elderly man, woman also comes down on the list, which means that this kind of age aspect is kind of not driven only by 1 character, but driven by multiple types of characters. And this is a good point here to talk about that what we did is basically considered like a descriptive ethics. It's talk more about how people would behave or people think, which is kind of different from normative ethics, what one should do. And if we want to talk about normative ethics, Germany is the first country who started they formed a committee of experts. This is a group of the experts in different kind of aspects. One of them is a Catholic bishop as well. And this committee of aspects, they have put some kind of normative rules. And now here, if we look at what the public found versus what the experts found, we could see quickly that the humans over pets, which is in agreement. This is also in kind of agreement, but then young over elderly is in clear disagreement with what the experts have said. And this is an interesting point now. There are also another disagreement because now we can see the public versus the experts have kind of a big disagreement. Next, we also try to do this at the country level. So we could calculate the same 9 numbers at the level of each country. We could also calculate distances between every pair of countries and then use a hierarchical clustering to do kind of put a whole dendrogram of all of these countries, how close to each other in their answer. And we do some kind of external validation with another classes that are proposed by some anthropologists. And mainly we find 3 big clusters. One of them that has a majority of Western countries, we call that Western. Other one has a majority of Eastern countries. You would see those are kind of South Asian and Islamic countries. And then the last one has kind of like two subclusters, one of them Latin American and former French colonies. We could also see, like, for example, how these countries comparatively, what are the preferences of these different clusters. The Western here, those are z-scores, of course. So the Western, you see, like, they're very close to the average. In general, they are like the biggest one. But we could see like a stark differences here, like, for example, between the Eastern and the Southern. Like a stark example is that Eastern country, the preference for sparing the young over the elderly is less pronounced in Eastern countries. Like Eastern cultures have like a higher appreciation for the elderly.
Looks like a 0 there, is that right?
Yeah, but this is like in comparison with the others. We could also try to see what factors could predict these kind of differences. So these are just correlations. So one of the measures that are used in anthropology is how individualist versus collectivist society is. Individualist society, people like trust institutions, they care about individuals, while in collectivist society, people don't trust institutions, they seek their extended families for protection, and you see like family ties are stronger. So individual societies are more like egalitarian. They think that more people are always better than fewer people, no matter what. We could also, another factor like rule of law, how strong the rule of law is in a country correlates with how willingness of people of sparing the lawful. Now, one indication that comes out of this is that now we could expect that if there are like normative rules that are being implemented in different societies or different countries, let's say if somehow driverless cars are implemented in a way that could disadvantage the jaywalkers, and if this rules is like universally applied in many countries, then this type of rule might get different levels of pushbacks in different societies. So some societies might find it okay that the jaywalkers should be punished in terms of the having higher risk, and other societies they would probably find that unacceptable. This is pretty much it.
Okay. Yeah. Well, great. That's really fascinating stuff, and I'm sure we'll get some questions on it. I want to come back to something that you said a little bit earlier. It relates to what Susan said at the opening, this difference between descriptive ethics and normative or prescriptive ethics. I mean, it really maps pretty well, I think, to this idea of, are we trying to replicate what most people are normally already doing in their decisions, or is there some, better set of decisions? But one thing that sort of emerges from that, in some things, if you're a company and you have a profit function, maybe it's a little bit more obvious what your goal is, although I think there are people who would debate what the goal of the company should be. But in the case of the car and the trolley problem, I guess you're relying on a group of experts, and maybe you could say a little bit more about, do you see that as the true measure of normative ethics, or is that just another approximation?
I mean, I guess this question also comes through also political philosophy, like who should decide this thing. And usually with in a democracy, you would expect that an elected representative is going to choose a committee of experts, like in the case of Germany.
I thought you were going to say in a democracy you would have the people decide.
Yeah, and I mean there is like also representative democracy.
Representative democracy. Yeah.
So in that case, the representative person who would be able to choose this kind of a committee of experts, and those committee of experts going to put these rules together, and usually they are chosen from different backgrounds, like as you saw here, so that they could all weigh in on this way. Now, those committees of experts, usually they have the public interest at their heart, but rarely do they know what the public interests are. So we cannot just say, usually like philosophers count on their intuition when they put normative ethics stuff, but they also in many cases they fail to.
There could be like a feedback system here that they see what people actually care about or say that they care about versus what they thought they should be caring about, and maybe both of them could learn. But how does this relate to the decisions we're making in company? I mean, for Susan and Dean here. Listening to many of the talks today, or in general, you get the sense that often picking the right objective function is one of the real issues where things can go astray, people focusing too much on the short term versus long term, or things that are measurable versus not measurable. I mean, how much of an issue is that part of the core problem that people like Cathy O'Neil are worried about?
Yeah, so are we talking about, like, for example, in terms of the model themselves, like how the model is being shaped versus also the type of data that's being used for training?
No, I mean the objective. I mean, if it is really maybe more for Susan or Dean,
yeah.
Specifying the objective function, how big a problem do you see that as being, and is that part of why there's this backlash?
I think that's usually a huge part of the problem. Even on like seemingly simple matters, it's often hard to get people to come to a consensus about what criterion you should use to make decisions. And so, I mean, just thinking about, especially as you move into more and more realistic variations on, say, this problem that are more and more statistical, where, driving that much faster increases your chance of killing a dog that might cross the road, but also it means that people get home and get to spend more time with their children. So that really starts to put it, I mean, obviously, I think it's great that you guys chose these really stark and clear options, but a lot of these policies are going to be more subtle and are going to involve trade-offs that people, I think, may find undesirable even to sort of think about some of those trade-offs, right? Like, if you say, should we go faster?
And we'll get the mics to go to you.
Yeah.
But that even presumes that you think to ask the question. I get the sense that oftentimes people aren't stepping back and taking that step. When Facebook was optimizing for engagement, seemed like a reasonable thing to do, but I'm not sure they fully thought through, at least from talking to some of the people there, what some of the implications were for the kinds of posts that were likely to make it to the top, things that got people outraged, or the thing people found to be unbelievable were more likely to be shared. Same thing on Twitter and elsewhere. So when maybe if they had stepped back and thought about, okay, what are these trade-offs, then you could have had an ethical or CEO level debate. But part of the problem may be that it doesn't even rise to the level of thinking that you're specifying the wrong production function.
But I think maybe addressing that kind of specific example, I mean, one of the things that comes up a lot in those settings is that some things you can measure much more precisely than others. And so then even if you're making a huge effort to measure the right things, I mean, I'm sure many of us have probably been hit by a lot of surveys by some of these tech companies about, the trustworthiness of things we're seeing in our news feeds, et cetera. Even if you're trying to measure that, the precision is so much lower than some of these other metrics. And so I think that can really shift the decision-making process. And so perhaps as a community, one of the things we can do there is try to really further advance the techniques we have for things like using surrogates for these outcomes that we really care about, increasing the precision of experiments, and not assuming that even very large firms can always have precision about everything that they care about. That's one way that our community can contribute, is making it that much easier to actually track the metrics that are really what we care about.
Yeah, and I would just maybe to pile onto that, I think some of the more sophisticated and thoughtful firms have collectively found sets of techniques to help guide and keep things safe. So, whether it's in the search engine, you realize that you're not able to fully understand what's going on from clicks, and so you supplement that with human panels of judges that audit the results to try to complement the clicks. And in an A/B testing platform, you don't just look at the metrics, but you might also have peer review. So if you're worried that somebody might have improved the metrics by something that looks good today, but would look bad in the future, if a peer group reviews it, they might say, well, yes, you've increased engagement, but it's in a kind of a gimmicky way. And actually, when you
mean like a peer of other data scientists?
Yeah. So this is something that some of the firms I work with do, is that they complement the A/B testing platform with peer review of the innovations. And so then you have to explain why your innovation worked, and you have to write it down and say, my innovation increased clicks because we improved relevance of the algorithm. And then the peers would have to assess that, and it's not that you improved clicks because you changed the background color or some other kind of more short-lived type of manipulation. So I think that as we go forward, both for A/B testing platforms and for algorithms broadly, which are often governed by A/B testing platforms, we need to develop sort of a collection of organizational processes that represent the objectives that are too noisy to be on the scorecard, or that are perhaps take too long to be on the scorecard.
Well, that peer review is really interesting, because it's sort of replicating or recapitulating the stuff that we do in academia, maybe for a good reason. And it also gets at that you want to get to an understanding of the causal model that's underneath it, not just that this worked for some inexplicable reason that make you feel a little uncomfortable with it, but rather that here's the rationale why it works or why we think it's working, and that gives you more confidence in it.
Yeah, and I guess if I try to go back into an analogy to like empirical research, if I built a model, 20 years ago, I ran a regression and I tried to make a causal interpretation, I would go around to a whole bunch of seminars and people would beat me up and they would look at the coefficients and they might say, well, if you extrapolate in this direction, this makes no sense. And, gosh, this functional form implies that, introducing apple cinnamon Cheerios, tripled GDP, and so gosh, like this doesn't make sense. And we had a whole kind of collective way to evaluate models and their reasonableness, right. And then we would spend a lot of time on each one. We usually, even the ones that got published, we didn't fully believe them. We only believed them under a certain set of circumstances, when the world looked like this, and as long as it didn't change like that.
It's very rare that a paper have just a table of regression. You'd have to usually have a theoretical model that justifies it, usually some story or some anecdotes or sort of in the beginning that says why this is a plausible thing to be doing. All those parts together collectively make for the
robustness checks,
alternative explanations.
Exactly, whether or not we think these results are generalizable. And so I think what's happened now is that the needs for all of those things haven't changed, but now so many more people are building models so much faster. They're complex. We don't really understand how or why they work. And then we need to come up with a much more scalable way to do this thing, which we used to have, incredibly smart experts spending an hour and a half at a time, multiple times, to really evaluate a model. And now we've got a data scientist who's, just come straight out of school and they're making big salaries, but they don't have a lot of experience. And we're using them to make real decisions, and we don't have that same kind of process around them. And we're not ever going to be able to spend that many hours and intelligence on each one.
In part because they have to react a lot faster. There's a lot of money on the line, so we can't wait 2.5 years for the Quarterly Journal of Economics to finish the review process.
Exactly, and of course the models are now more complicated, so you can't just inspect them in the same way. And so I feel like actually in 10 years, my forecast would be that collectively all of our organizations and universities will have developed a set of organizational processes, review processes, tests, queries, to try to help make sure these things are safe. But even then, or safe, fair, ethical, but even then, a lot of it will be domain specific. So, the unintended consequences are different. Like, Ronnie and I know from search, you do an experiment on, 1% of traffic, and if the prices go up on 1% of traffic, that's fine. But if you increase prices on all of traffic, the advertisers run out of budget, and then, the next week, revenue crashes and you have this disaster. Well, you figure that out in search or in advertising, but there's going to be some other set of unintended consequences in cars, and another set in loans, and another set in fraud detection, and so on. So it's actually, I think, when people think like, oh, the robots are going to take over the world, and this just because we can play Go and climb, or have a robot climb over a wall, or play Pac-Man, that we're about to solve all the world's problems, like I feel like no, actually, it's so hard in each environment to really understand what you're optimizing that it's going to be actually much more of a slog to make each of these things work well.
So let's come back to a little bit, because I know that you guys also have something to say on that, because I think there's a question over here, right? And if you just raise your hand, and the mics will come to you, and then we'll get the audience, everyone will get a chance as well. So go ahead.
I just had a question for Dean, I guess, and generally. If, I guess, algorithm bias is a causal inference problem, I was just wondering what you think is like the role of experimentation to kind of solve that problem, and then specifically in like settings where experimentation is hard, like reviewing job applications or looking at like where to police in a city.
Right.
Yeah, I think that's actually a
jail
great
percentage of the population to see how that changes the crime rate.
Yeah, I think actually that's really relevant to just sort of the discussion that we were having, is that one of the main tools that we'll have for at least in kind of a well-scoped version of this problem maybe not considering all of these kinds of unintended consequences. But the narrower problem is to be able to do audit studies at a much greater scale without worrying about some of the consequences that we have when human decision makers are involved. Some of the ethical issues that come in running audit studies where, say, you send out resumes that randomize characteristics of the people whose resumes they are, is that this does impose real costs on people to the extent that this is actually all screened by algorithms, and that those algorithms can be put into kind of a clean room environment and tested. There's a lot you can do there, and maybe that's something you can comment
well, exactly.
on.
I think you've described something, this concept of a Turing box, which has been described using other words, but that might be a way to get around this issue, because with data you can simulate things.
Yeah, so one way to think about this is to think about the machines and algorithm as like actors that you could actually study, like experiment with them and study their behavior in the same way that social scientists study humans. So you could think about like you put an algorithm there and you try to give it, like experiment with it, like send it to different types of resumes and then see how it's going to give the outcome out, and then you can test on like millions or like hundreds of thousands of examples, and then in aggregate you can make these calculations. And in our group there is this kind of project that we've been working on, and it's actually meant to kind of to bridge the gap that Susan just mentioned, which is basically between the number of algorithms that are being implemented and the social science studies about those algorithms. So the idea is that it's like a two-way marketplace where like computer scientists and developers can upload their algorithms, and then social scientists can try to test those algorithms by experimenting with them. Like, for example, sending them different, two very similar.
So this is a huge advantage the algorithms have over the humans. Is we may think that some humans are biased, we may think that some algorithms are biased, but it's massively easier to test the algorithms and say, okay, there's a small hint that you're prejudiced against this group or another, maybe unintentionally. There's nothing in the code that we can see that says this, but with a neural net or whatever, it might be impossible to point to a particular weight. But you can, as you say, give it 1 million examples and start noticing if there's a statistically significant pattern there that the developers may not have even intended, and then you can go back and you can adjust it and learn from that. That would be very difficult, if not impossible, to do with human decision makers, in part because they're just not very consistent, right? They're noisy and they're very costly to do that kind of thing.
You can also like test it for edge cases, for example, which is something that would be kind of sometimes like horrible to do with the humans as well. So you could write like some specific kind of scenarios that are probably very, very rare, but when they happen, they kind of have like very big consequences.
Well, you do have to be careful with the edge cases too, because if you have a very nonlinear system, it may or may not be representative. But yeah, it's something you care about. I think there's a question over here. Yep, Sinan.
So this is not well formulated, but maybe you'll bear with me for a second. Do we care about defining algorithmic bias in the space of all possible outcomes for an algorithm, or only the space of outcomes conditional on the data that algorithm sees? So let me give you an example. Across down the street, there's a big court case now about whether there's bias in admissions at an unnamed university down the street. And Bin Yu and Ben was visiting, and she was in my office, and we were reading some of the documents in that court case in my office, and we saw a graph which showed the number of Asian applications and the number of Asian acceptances, and it had a bunch of lines that were flat for all the Ivy Leagues, one line going straight upwards for Asian applicants across the board, and one line that tracked that Asian applicants for Caltech. And she said to me, this is clear evidence that there's bias here. And I thought to myself, well, how do we know that there aren't at least 2 subpopulations of Asians, one of which applies to Caltech and one of which applies to the Ivies, where there's some other differences? And the question is, does it matter if an algorithm is biased if the data that it needs to receive in order to be biased never occurs? Do we care only about the algorithmic bias that realistically happens, or do we care about the space of all possible bias that the algorithm would produce if it got any set of data to produce that bias with?
Yeah, Can I?
Go ahead. I mean, it's a good follow-on to what you were just saying, I think.
Yeah, I think this is a very interesting question, and I've been thinking about this. That, for example, do we do this with human? Like, do we try to test if the human's going to do well in hypothetical scenarios that's going to happen? And I think there was some the only example that somebody mentioned to me is that if somebody is known to be like maybe they might be pedophiles, then they might want to quarantine them or something. But in general, we don't do that with human. But there might be a good reason to do that with algorithm, because first of all, as I said, edge cases, if they do happen, they might have big consequences. And the second thing is that the same algorithm is being implemented over and over, and all those any kind of small fractions is going to be materialized somewhere.
I mean, it seems if it's a situation that never occurs in the real world, at first approximation, maybe you don't really care about it. But if it does behave bizarrely in an edge case, maybe it tells you something about the underlying decision that's going on. It's not what you thought it was. And so that might give you a little bit of a cause for concern that even though it seems to be doing the right decision in all the observable data, this weird case over here is, I would say that would be kind of a red flag.
Yeah, so
Yeah, well, that's another reason is that it could be, yeah, exactly. It could what's out of sample now might be in sample in the future.
Black swan event.
So I think this relates to the broader concept of transparency as well. And there's a question of why do you need to know how something works? And these edge cases might help us understand how it works. Now, there's a version of interpretability and transparency which goes a little bit like this. We're the brilliant scientists who build the brilliant algorithms. It's sad for us that people don't like to listen to them because they're a black box. And so now we need to figure out how to interpret it to convince those dumb humans to listen to our brilliant algorithm. I actually kind of have a different take on that, which is that, going back to Ronnie's examples this morning, I've spent my whole career picking up health advice in the New York Times and other types of empirical claims which actually are completely not plausible. And so my general reaction is if an algorithm was giving me advice about taking an action, that algorithm, if it's telling me what to do, had better be good at causal inference, and it better have had some experimental variation in the data. And if you can't explain to me how this algorithm came to have the capacity to give me advice, then I surely don't want to listen to it. And that's actually because I'm smart, not because I'm stupid. And so I guess, getting back to then transparency, at some level, if we're going to use algorithms to drive actions, then in fact they need to be transparent as to why they're making the recommendations they do, what kinds of recommendations they can confidently make, why they would know better than me, and also uncertainty quantification where the algorithm actually has no idea, or whether the algorithm actually doesn't have enough experimental or quasi-experimental data to actually make a recommendation. That's a lot to communicate to people, but it's what I would need to know to use it to make a decision. And it's actually, when I talk to people in firms, that I do these exec sessions, and the tech people are like, we built this great algorithm, and the salespeople won't listen to it. And then the salespeople are like, you shoved this algorithm in my face that says red or green, and and it doesn't really conform to my intuition, and I don't really trust it. And of course, we need to have some better way to make these transparent, not because the salespeople are stupid, but actually because they might be smart.
It raises, what you're raising is a broader point that most of the time, the algorithms are not in isolation, they're not on autopilot. Even when you think it's not a human-machine symbiosis, at a bare minimum, it's almost always that the human gets final veto of whether to even use it. So at that level, it's a symbiosis. And often, it's a much more explicit symbiosis where they do have to coordinate. And there, it's clear that interpretability will help the human be able to make better sense of what the algorithm is recommending, and the two of them can make a better decision that way. So those are a couple of reasons. Although I would say there are situations where where you can have human-machine symbiosis even without interpretability as well, and it could still benefit.
Sure. I mean, and so I guess if I thought about like an algorithm, reading somebody's LinkedIn profile and summarizing their network and then coming back and giving me a network score, like that could be a useful input. It's automating a manual process and it's a nice score. But part of interpretability to me is if you're recommending a decision, it should be causal. And I hope you had experimental data. So to me, interpretability should be partly about how they come to the decision. I don't mind if it's a random forest or a neural net or whatever, but I actually want to know qualitatively what information could it have had to help me make a decision.
But those seem like two slightly different kinds of interpret.
Yes.
One is almost kind of a one-off. Does this algorithm do what it's supposed to do? And once you've kind of gotten confidence in that, you no longer have to have it sort of in real time telling you. Another is sort of in real time for each decision explaining how it came to it. The former is useful to sort of understand the reliability and whether you should put weight on this output. And the latter is useful as you update your own decision making.
Yeah, so I want to highlight that there is some kind of work about interpretability that relates to the causal inference. There's work by Sandra Wachter, which tried to see like how to generate interpretations given like a counterfactual. So, for example, we will say, for example, you were not qualified to get a house loan because your salary was $30,000. If your salary was $40,000, you would have qualified. And then this is, of course, not as easy as it seems because sometimes there are multiple variables that could have been changed, and then the way to choose what is the best way to present.
Well, in general, as the models get more sophisticated, there's going to be 10,000 variables that maybe could have changed, right? So it's going to be rare. I mean, that's one of the issues as the models get more complex and maybe I could say sophisticated. It gets harder and harder to explain them to a human, and that's a sort of an inherent trade-off.
And I guess I would just pick up there a way that our community can continue to contribute. And so one of these is around, okay, where is the sort of experimental or as good as experimental variation in the data? And so we might be some of the people producing that variation. And then even just from a very technical statistics and econometrics perspective, that's an area that's still developing, right? I mean, I've been to a lot of structural econometrics talks where people say, and this parameter is identified off of the high frequency variation in price with no evidence that that's true. And it's only recently that, say with some work by Isaiah Andrews where they're saying, actually, we can test whether certain parts of the model were really identified by the experimental variation. And these are tools that are going to be useful for understanding, well, how much is an algorithm that's making important decisions relying on some really strong assumptions about observational causal inference, and how much is it actually able to leverage the sort of known experimental variation in the data. So there's a lot of room for us to be contributing there.
Great. Let's get some more questions. One over there. Yep.
Is this thing on? Yeah. So partially comment and then a topic. So I work for one of those companies that has baked peer feedback deep into the experimentation system, and a lot of the comments that Susan is making resonate with me. And I feel like there's sort of a fundamental problem, elephant in the room, that is not being acknowledged. So I want to connect the dots of some of the things that have been said. Dean is right that some things cannot be measured with enough precision, and one of the problems I see is a false dichotomy that Eric was pointing out, which is long-term versus short-term metrics. There are no long-term metrics. There are only less short-term metrics. And many of the optimization functions that we try to optimize for are actually in the limit. So if we're talking about profit, we want profit in the limit. And so we can approximate those functions, but we can never really attain them. And then the third problem with trying to optimize for a single optimization function is the recent work in Nature is that we fundamentally disagree about things that we think we should have agreement about. So the fact that we cannot agree about what is moral is not an abbreviation. That's quite common, and I think the same is true for many optimization problems. So I think we have to acknowledge that having a single metric that we optimize for is not just difficult, it is fundamentally impossible. And so explainability or transparency are the only way that we have to control these mechanisms, both for optimization and for experimentation. And so we have to find ways that we can apply things like peer review to these machine learning systems, to these automated systems. So we've already talked about peer review, but I would like to hear from the panel, how can we apply similar techniques to machine learning?
And it sounds like to the goal function too, or I mean, it may be impossible, but we have to do it nonetheless, right?
So we have to measure something, right? And so even in medical trials where we optimize for something, we are not actually optimizing for the thing that we want to optimize for in medicine, which would be a long and happy life. And there's not a single doctor in the world that is measuring that in a medical trial, right? So even there we are using approximations for what we actually want to achieve.
So go ahead.
Feel free to disagree, but I don't think we can ever optimize for the thing we want.
Yeah, first I want to talk about, with respect to the disagreements, I mean, the only way is basically to choose something that would, actually that is sensible and that is justifiable and defensible, and then implement that and make it clear for everyone that this is the thing that is being chosen. Now, how to choose this thing, this is another question, but this is how it's happening in the law now, right? Like, so the law is basically taking some kind of views in ethics that implement those point of view. Not everybody probably agree with those things, but the idea is to choose something that works, because if you kind of leave it to like philosophy, for example, nothing is agreed on at all in philosophy.
But it's widely understood that the law is not the same as ethics, and that there needs to be a way to appeal to the court if the law is wrong, right? Yeah, so we have these systems in place for the law already.
Yes. Yeah, I agreed. I mean, this is available. There are some channels, as you mentioned, with respect to the law, right?
It's a good analogy, because there we have actually recognized that this is a problem and tried to fix it.
So this seems like a very deep and important point, that as we get better and better at having machines do our bidding, it becomes more important to be able to specify what our bidding is. What is it that we want? And it came up, obviously, and you had a very simplified, and I mean this as a compliment, like stylized, overly simplified case. And even there, it was, people had a hard time making these moral decisions, let alone in a more realistic situation when there are so many other considerations and variables. And we see it in a lot of the decisions that one of the reasons I think that there's this backlash in the books like Weapons of Mass Destruction is that companies think they're optimizing A, but they're really optimizing B. And then when they sit and try and think about it, it turns out to be surprisingly difficult to define what it is that you even want to optimize. It's an interesting problem for humanity to have, that we can achieve what we want, but we don't know what it is we want.
Yeah, my experience myself, and talking with other people who've done consulting or worked at companies implementing, say, multi-arm bandit solvers, the first thing you find out is that, yeah, it'll optimize the hell out of whatever you told it to optimize, and then someone will come over your desk and start yelling at you.
Right, the fastest way to find out that that's not really what you...
It's a really fast way to find out that's not your actual...
Suddenly you realize that, it's like the Midas golden touch. You think, yeah, that's what I want. Oh, wait a minute, you're actually going to give that to me?
Yeah.
Yeah, that's interesting. I think there's a question over on this side, so let's do that, and then we'll come back to the middle. I'm having this faux diversity of picking different geographies.
Hi, I was intrigued by the statement about how algorithmic bias can be framed as a question of causal inference. And I think, well, it seems as if the discussion has mainly been about evaluating policies using causal methods. And so I'm wondering if you're aware of efforts and research in industry, maybe your own work, about building prediction models that are constrained by causal structure, or very basic assumptions about causal structure. For example, telling an algorithm from the beginning that gender has no effect on performance, and then forcing the prediction model to be built with that particular constraint in mind.
So I think that's a really interesting research area, and actually, but I think one of the first things I thought when I went to the search engine 11 years ago was, like, okay, I'm not going to be able to like make the whole click prediction model fully causal, but if I had the power to make a more sensible click prediction model, like how would I bring in certain constraints? Because I can't run it all as a big IV regression or something. And so, you know, one kind of, I think there's a bunch of different tactics. Like one thing there is like if you run experiments and you figure out what the click curve looks like, you know, the click prediction model as of day one was overestimating the benefit of being in the first position, because the model, even though the model put good things in the first position, when the model ingested the data to estimate the effect of being in the first position, it forgot that it had put the best things in the first position, and so it wasn't reweighting the data or focusing on experimental variation.
Is that just a flaw in the design, though?
I mean, that's what as of circa late 2000s, every click prediction model that I was aware of made these fundamental causal inference mistakes and so I was like kind of stunned by that. I was like, wow, how can all these people be making billions of dollars building these models that are ignoring basic insights from causal inference? So one like fix that we did was we actually like ran an experiment, estimated the position effects from the experiment, and then shoved them into the model and didn't actually allow the model to estimate those on the fly. Now that worked with a particular functional form implementation of the model, and then when that changed, that all went out the window again, and I have no idea what they're doing now. But
conceptually, you could keep doing that.
Yeah, conceptually, I think one idea is to sort of pin down parameters that you know. But I think, actually, I thought at the time, and I still think today, that that's a great research topic of like how, in a world where you are really constrained to be mostly using observational data, how can you prevent it from making kind of common correlation causality
Maybe some things you know from theory or from other reasons that you know that
or
this number has to be 1, that number has to be 3.
Demand curve slowed down.
Yeah. And so we just bake that in. Please don't try to learn anything different.
Yeah, because of course, you know, in most data sets, if you use observational data, you'll find that demand curves slope up, that higher prices are correlated with higher output. And of course, we generally know that that is almost never true. So trying to constrain the model to find sensible solutions is I think, a really interesting area.
Let's get some other questions. I think there was one near the middle somewhere. Is that right? Yeah, here we go. Sorry.
Is this working? Okay. So I guess it's somewhat related, but from a different angle. We're talking about all these possible rules and morals and ethics, but there's already now just kicked in the last year the Gdpr, which is infecting everywhere and infecting in a good way, I think. And it's hitting lots of other countries as well, and impacting countries that are operating in whatever space. Which brings into the story the issue of, for example, use of algorithms, ability to know what data is collected about you as a subject, ability of yourself to correct your data. So there are a lot of these things that we're talking about that are already in this new regulation. How do you think about what's going on there and how that fits in? As academics, we kind of live with that through IRB, the ones of us who actually know what IRB is. But for companies, this is kind of new turf.
Thoughts? I mean, Dean and Susan, you've both been in companies, admittedly maybe pre-GDPR eras, but
yeah, I mean, I've had some
friends?
light contact with GDPR-related things, and I guess one of my conclusions is that a lot more expertise is needed in some of this area, especially getting a couple kind of the overlap in the Venn diagram a little bit larger between what the lawyers understand and what the technologists understand and what the social scientists understand, because I think many companies are just sort of waiting to see what actually does any of this mean, right? So I mean, we're talking about fairness, accountability, transparency. I think that researchers working in that area have come up with, I think, at least a score of definitions of fairness. And so then when a lot of the notions some of them are somewhat ambiguous in the context of GDPR, are then you try to map them onto these, say, more formalized notions of things that you should be doing, it's unclear how they always map up, which was why I tried to be careful about not saying that I wanted to say anything about disparate impact as a legal concept, as opposed to as a formal one that has been given a slightly different name for that reason of avoiding that collision within the fairness literature. So I think that's one of the big challenges. Some of these things may not match up. And in fact, many of the fairness definitions, for example, are incompatible. You can't jointly satisfy them. So, and I assume that many of the things that we think might be morally or ethically desirable will sometimes be incompatible with the law as well. So, but mapping those things together, it sounds difficult to me.
Let me ask a follow-up on that. I mean, so I've talked to a bunch of folks in these mostly big companies about GDPR, and I was actually surprised at how accepting and positive it was. One person said to me, this is fine, we're gonna have no problem, it's not gonna make it any harder for us to do what we're doing. And so there's two interpretations that come to mind. One is that this really is something that it can manage. You can still do, the kind of analysis you want to do, and that it's all good. I hope that's the interpretation. The other interpretation is that this is a terrific barrier to entry that helps the big companies and is very difficult for the smaller companies. And lo and behold, the big companies are all for it. Which of those?
Well, I think that just gets back to we want to have informed regulation. But yeah, GDPR has been, I think, is very good for Google, for example. And there's people are often not thinking through the consequences of regulation. And I just maybe to pop back on the regulatory point a little bit, I think we are definitely not prepared for this new world. So, like, say, banking regulators trying to understand a credit scoring model or something. They used to require every 6 months a big white paper describing your credit scoring model. They need to have a new way to evaluate that.
Or they're being end run around the Ant Financials of the world that have, probably much more sophisticated models using lots more different kinds of data that apparently are outperforming the old.
Right, exactly. So then there's
without any regulation.
International competition. And then another part of the regulatory environment is that, human processes were regulated, but there was no idea of a measurable error. Now a company will have a demonstrable error because, of course, if you have a statistical algorithm, you can demonstrate that it has an error rate. And in some cases, the regulations aren't really set up to acknowledge an error rate. And even if it's not the regulations and the law, there's also the court of public opinion. So in some sense—
a different way of thinking that lawyers or most lay people, they think there's like a right and a wrong. And like, why are you doing this where that some percentage of the time you're wrong?
Right, and so I think companies have to, and universities and everybody, we have to think about, like, what is our obligation when now, in principle, it's possible to find our errors. Like, for any particular thing, if you had just taken, you had all the data, you had the models, if you had just pushed this button, you would have noticed that you were actually allowing people to gamble away their life savings. And in the old world, it might have been hard to figure that out. But now, in fact, maybe you created 2,000 segments and one of them are gamblers, but you just didn't take action on it. So suddenly, in some sense, we have to get this back to the cars. Like, we didn't used to think about making a decision. Now we have to make so many decisions. We're forced to make decisions. We didn't want to make those decisions. And in fact, when you make them, it's now documented. If you go back 5 years from now, a regulator or a subpoena will be able to do empirical analysis and look at your data and see how you made the decision. And you might be held liable or judged morally or ethically for things you did or didn't decide when in some sense you weren't really set up to decide.
It sounds like ultimately that, this group is biased, but the statistical way of thinking about it is the right way to think about it, and there's a lot of re-education that has to happen for Congress, lawyers, and even lay people to the extent that they're weighing in on that. That sounds like it's going to be a difficult
The statistical education was partly you have to understand the concepts of error rates and testing models and stability and a bunch of other concepts. But then there's still the question of there's like cost-benefit analysis questions. Like, all of you guys in firms are expensive. You actually don't have time to figure out everything you possibly could do with your data or to eliminate every possible risk. And so the fact that you didn't act, how there was a cost-benefit decision that was made, or you decided not to intervene in a certain setting, or to take a risk that somebody died, and at some level you're not going to be able to eliminate risk. So, but now it's there in black and white that you made the choice.
You could hide it before, but now you can't even hide it. So, can we see how many people have their hands up? So there's one here, there. Okay, so let's start over there. Did you have the mic already in your hand?
Sure, yeah. So I can understand why we need an auditing system for our modeling, but I cannot understand why humans should do that auditing. The best machine learning algorithm that I'm using and I'm building are not explainable. When I'm trying to make them explainable, the accuracy is not as good anymore. So, for example, in a loan example that you mentioned, yeah, it's very good to explain why your loan is get approved or not, but you're assuming it's a human who is applying for the loan, but it might be a machine who are applying for the loan. As long as I can have a trusted algorithm at my home and ask the algorithm to apply for a loan for myself, now it's a two machine or two algorithm are negotiating and talking with
Good.
So I guess just to, I think, getting back to my earlier points, your algorithm, you know, you say that it's a trusted algorithm, but is it trusted? Is it stable? If it's, you know, I don't care about it being explaining.
Let's go ahead and stipulate. Let's suppose, you know, to make it cleaner, that you've got an algorithm that's trusted, you know that it's 98% reliable.
Uniformly 98% reliable across every observation.
Exactly.
The uncertainty quantification is there.
And then there's another one that isn't as reliable, but that is more explainable.
Well, I thought the query was more about this idea that I have this reliable algorithm that's working on my behalf, perhaps in a somewhat adversarial situation with others, right? I mean, that I'm maybe delegating to an algorithm that's going to represent me in my loan applications, in how I set prices, et cetera.
And I guess I would just go back to say that you know, doctors that don't question how a laboratory actually comes back with the test. The doctor just wants to know the false negative and false positive rate. So I actually don't think that humans really care about looking under the hood if it actually is trustworthy. And I think the problem is that most predictive models aren't actually
Should we have a certification authority, an underwriter's laboratory that we send the algorithms to?
Well, and
the Turing.
And they don't express the uncertainty, and you're not given, you know, statistical confidence or usable statistical confidence around things. So I guess my personal view is that I don't care if it's explainable, and I don't think other people care if it's explainable either, if it's actually giving you the information it claims it does. But the empirical fact is that most models aren't.
But if it's giving you that information, so how do we decide? I mean, so that was a real question. It wasn't just a hypothetical. Should we have some body or some way of certifying them so that each person doesn't have to do it a la carte?
You can, I mean, of course, you can use an experimentation platform to evaluate your algorithm. And so that's like what we do with drugs. We put them through randomized controlled trials.
Exactly.
We put algorithms through trials, and we actually demonstrate
Federal Algorithm Administration?
Well, I mean, it doesn't need to be federal. If the algorithm is helping somebody decide to make a loan, it's just something that happens inside the firm. So I guess my personal view is that a lot of this emphasis on interpretability is really misguided. Like, I think it's actually a mistake to say, oh, let's just generically look for friendly-looking algorithms. I actually take a much more functional approach, which is my goal is that the algorithm is good. It might be that as a means to an end, it needs to be interpretable or simple because that regularizes it or it avoids overfitting or it makes it more stable or it's causal, and generally causal is the thing that works the best, but it's a means to an end and it's not the complexity itself that's the problem.
But sometimes, like, also the human perception is also an important factor because then it can impact the adoption. And like one thing that people kind of probably, you know, trust algorithms less is that we don't have a theory of mind of those algorithms. Like, unlike with humans, if I'm driving and I see someone else driving on the road, then I kind of somehow like have a model of how they think, how they could react, how they could do. But with the self-driving cars, I still don't know how it's going to be reacting, how it's going to be making those decisions. So if at least I have an understanding of that, I would know how to react to that. And I think people have probably the same mentality when they want to buy a self-driving cars because we don't know how it's making those decisions. So this could influence the adoption. And
right. Although it's not all good. Dean and I were talking just before the panel about how people are developing a theory of how Google cars react and taking advantage of it. I mean,
yeah, which is that they will let you merge in front of them at the last minute. right? So if you drive in an area where there's a lot of self-driving cars, you know that that's who to cut off.
You can start bullying the self-driving cars.
And I would just agree with you. And I would actually put this theory of mind as part of the means to an end, that it's part of understanding its effectiveness. But it's not that I want to understand what's under the hood because I care about what's under the hood, but I care about it because I need to know. As a decision maker, I need to understand it at some level. And that's actually, it's pretty hard though. So I think that's going to be like a whole science.
You need to know, but if you knew the reliability, if you had this Turing box and you could prove that over the range of reasonable data, it gave you the results that you needed to know, would it matter to you that you didn't understand all the weights on the 1 million neurons?
Exactly. No. Right.
Question over here.
Okay. So it seems like one of the biggest challenges really is going from whatever we can measure with our inputs, outputs, okay, we can do a Turing box, we can analyze it, but really the big question is what will differences in systematic differences in micro decisions that are likely to be automated now and in the future, what will those lead to, right? What are the consequences that will bring to our social, political systems, economic systems, etc. So that really brings pressure on the social sciences. For me, this is a real question for the social sciences. Hopefully, and luckily, we have a movement towards computational social sciences. And I think that's a healthy move because there's a mismatch right now between the micro level of automated decisions, targeting decisions, judges, bail or jail decisions, etc., and the large-scale consequences of those decisions. There's a mismatch, and social sciences are not prepared to answer, to connect those two things. And hopefully we have computational social science that tries to go towards that level of complexity.
Most of the time when people use the term compensation, it's kind of in the other direction around. It's applying machine learning systems to social science problems. But I think if I understand your question, you're talking more about using social sciences to understand the implications of what machine learning is doing for society.
Yeah, my view would be that, exactly that it's not that we need computer scientists to study social sciences problems, although we do need that, but we actually need the disciplines of the social sciences about measurement and understanding unintended consequences and human behavior, ethics, and so on. So this human-centered AI initiative that we're launching at Stanford has that as really a central component of it, and that's one reason that I'm involved in the leadership of that, because I completely agree with you. And I think it's like wide open. It's hard though. It's not like I can just, give me $1 million and I can come back and
how about 500 million?
But and just come back. There's no amount of money where next year, any of us could come back and say this is what AI is going to do to labor markets, inequality, and our society. These are just.
We'll try.
We're going to try really hard, but it's not. We're not a year away or 5 years away from being able to answer those questions, and it's going to be a really broad, deep, rich research agenda.
Yeah, so actually my question was, what are your hopes that we can actually approach that capability of reasoning about the consequences of changing those micro-level decisions at the systematic?
One of the things that's hard about it is that it's hard to predict the future, and actually one thing social science is good at is measuring and understanding from the past, and in times of rapid change, it can be very difficult to do that forecasting. But nonetheless, I think one of the things that we're all well positioned to do is, when we're the canary in the coal mine, when we're the first ones implementing these things at scale, we're in a better position to forecast. So one of the things, when I saw the search engine in 2007, I was an auction expert. I was doing a tiny bit of econometrics, but mostly thinking about theory. And I said, shoot, this thing is going to change everything. Like, now that I see what a search engine can do, there's going to be, everything is going to change. And I shifted my whole research agenda to study it. But I still think the lessons of the search engine are really important. It was a complicated system, lots of unintended consequences, long-term, short-term trade-offs, feedback effects, market-wide dynamics. And in some sense, the people who cut their teeth there are then well positioned to go, and then a lot of them went to Facebook and be ready to figure out all the unintended consequences and market-wide interactions and network effects in Facebook. And then those people in turn, I hope they go off and make sure the self-driving cars don't all crash into us and drive off the cliff.
They'll do a better job.
So I think that is, we need to immerse ourselves in the technology so that we can have a better idea how to predict the problem.
We're just about out of time. Do you guys want to have any sort of closing thoughts on that? I think this is a really good broad point to end on.
Yeah, I think what I thought is important is that the last 2 or 3 years now, there is a bigger awareness about those things, and now people started talking about the ethics of AI, which kind of like all those decisions has been being done by these companies, not necessarily in a bad intent, but like optimizing for other things. And I think this awareness will help people to contribute better.
And I guess I would just say that I think things like, this Turing box idea and really auditing these algorithms in clean settings, that's a place where experimentalists can contribute a lot. These broader questions are cases like studying network interference and markets that are moving towards a new equilibrium, are things that also a part of our community is equipped to study, but sometimes is going to require stronger assumptions, more models, theories.
Yeah.
We have to recognize that, yeah.
That's right, and I think what we're hearing is that even taking it up one level further than that, in the broader social sciences, even philosophy and ethics, I mean, as we start being able to have tools, machines that can do all these things, it becomes more important to understand what our actual values are. And I know the philosophy department has been working on this for like 4,000 years, and like we're getting to a deadline soon where we're going to have to start getting the answers one way or the other. And likewise with a lot of the social sciences. So hopefully we'll make some progress with that, and with sufficient funding, we'll be able to do it a little bit faster. So thanks very much for to the panelists.